For some reason, the other video cut off and wouldn't let me edit, so I'm going to continue on in this section. We talked about LCD. The goal is to get each of those to have the same LCD, so this is missing a plus 1. This is missing a plus h plus 1. And this is missing all of it. So you multiply top and bottom by that, and remember, if it's a complex fraction, you would, by making all the fractions have the same denominator, you just transform that into a single fraction with this. That is a plus h into a plus 1 minus a into a plus h plus 1 over the h times this mess. So you just read the top of each fraction. And by doing this, I worked out all the 3 different types of problems that you come across. There's one more. There's a radical. You see a radical, you multiply with a conjugate. This will be, if you FOIL a squared plus a plus ah plus h minus a squared when you distribute, minus ah minus a, the a's cancel out, the negative a's cancel out, and the a minus h, a plus h cancel out. You're left with h over, and the h's cancel out, and that's pretty much it. You're done. That would be your final answer with a 1 over that mess. The last aspect we're going to talk about, I got to remind you of domain. Domain, allowable x values. In general, if I was to ask what's the domain on a function, you would say all real numbers, unless you see one of 3 things. You see a fraction, you want to ensure that the denominator does not equal 0. As long as the denominator doesn't equal 0, you're set. So your domain should be all values except those that make the denominator equal 0. If I see an even index radical, in case you missed it, that's the index. So square root, 4th root, 6th root. The radicand, the quantity underneath the radical, has to be bigger than or equal to 0. And if I come across a log with a base a of r of x, this is called the argument. Whatever you take in the log of must be strictly bigger than 0. So those are very close. Even index radical or logs are very close. We're not going to touch on logs yet. So for now, we start off with a bunch of examples. Find the domain of each function. Domain is a must. So when I look at each of these problems, I'm trying to figure out what values can I have. I see a radical, but it's an odd, it's not an even index. Since the 3 cases are not there, there's no log, it's not an even index, and there's no fraction, domain would be, this is how you write all real numbers, or you could write it in interval notation if you wish. This suffices, and if you don't remember that, you could say all real numbers. Not a big deal. Whatever works. Any of those will do. Part B, I see an even index radical. I take the quantity underneath the radical and set it to be greater than or equal to 0. And we solve like we did back in chapter 1. Subtract 2 from both sides. Normally, if it's an interval, you give the answer of the domain either by set builder notation, x such that x is bigger than or equal to negative 2, or it's habitual to give it as an interval. Either of those, you don't have to do both, one of them will do. Here I see a fraction, well, trying to avoid a 0 in the denominator. So take the denominator, set it equal to 0, so you already know 3 is the only value that you can't have. So either you say domain, choose x such that x does not equal to 3. This is saying any value of x, the condition stay away from 3. Interval notation is not wise because then you're going to say negative infinity to negative to 3, union with 3 to infinity. This becomes long very quickly. This is the more efficient way to do it. If you just want to take out a few values, Looking at example D, I want to take the denominator and figure out where does x squared plus x not equal to 0. I factor. So domain, I would say, choose any value, stay away from -1 and 0. Looking at E, x squared plus 2 bigger than or equal to 0, but x squared plus 2 is always bigger than or equal to 0. Since there's no way of that being negative, which is what I'm trying to avoid, the domain will be all real numbers. And if I come across an even index radical with a quadratic, I set that to be bigger than or equal to 0. We just did that in the previous section. Remember, we have to make, for now, the number line 0, 2, pick a point to the left of 0, say -1. Negative times a negative is a positive. A 1 is positive. 1 minus 2 is negative. Positive times a negative is a negative. And factor 3, positive. 3 minus 2 is positive. I want to know where is this bigger than 0, meaning positive. And those are included. So in this case, I would say domain would be -infinity to 0, union with 2 to infinity. And the last case, if I have a fraction and a radical, well, I'll work each of those individually. The radical, I'll say x plus 2 must be bigger than or equal to 0, so x must be bigger than or equal to -2. Now, it's ideal if you have multiple cases to put everything on a number line. So if I put the first case, x is bigger than or equal to a -2. So far, that's what I have. The fraction part indicates that x squared plus 5x plus 4 cannot equal 0. X plus 4 into x plus 1 cannot equal 0. X cannot be a -4 or a -1. So if I go on this domain that, if I go on this, and I say, let me take out -4, let me take out -1. Now, if I read this, what can I have? Domain left to right, -2 is okay, all the way to -1, union with -1 to infinity. That would be my domain. And that's pretty much it for this section.